power rule with negatives and fractional powers. So let's remind ourselves what the power rule is, that if you have y to some x, I'm already jumping ahead of the game. All right. Well, we'll deal with numbers in front later. X to some a. And what happens is when you take the derivative of it, that exponent moves out in front. And then we subtract 1 from the exponent. That's all there is to it. So whether you have negative exponents or fractional powers, you're still doing that same process. So d dx of our x to the 5 over 3. And remember, this is to the 5th power and cube root. So kind of remind yourself what fractional powers mean, because sometimes they throw those at you. All right, so when you do the derivative, the exponent moves out in front. So 5 over 3 moves out in front, x, and then 5 over 3 minus 1. All right, so now we just got to take care of what 5 over 3 minus 1 is. So here's my side work. 5 over 3 minus 3 over 3. I'm going to change 1 into 3 over 3. We have a common denominator, so that would be 5 minus 3 over 3, and that turns into 2 over 3. So this turns into 5 over 3 times x to the 2/3. So squared and then cube root. And that's all there is. 5 divided by 3. X to the 2 divided by 3. Ooh, hey, watch it. And the exponent, buddy. Divided by, nope. Hey, come on. 2. Let's try that. Nope. Come on. There we go. Gee, that was tough. 2 divided by 3. I'm not even sure how I did it, but there it is. Okay. Also, you could have it as like what I said with the 5 over 3. And if you can't figure out how to get the exponent, default method would be to write it as, okay, I need to write it in one of the equivalent forms with the exponents. And I saw there were square roots in the answer. So that's a cube root down there. That's a cube root. And then that's the square. So that would also be okay. All right. 5 over 3 times x to the 2/3. 5 over 3 times x squared cube root. Same thing. And then, I don't know if I want to, yeah, might as well. Here's the other form. I don't mind. Then all of this would be squared. So remember, these are all equivalent, just to kind of remind you of the different forms that this can take. All right, so they can definitely throw any of these at you on a test, but usually fractional exponents are where we stay because there's more algebra, more math, more versatility with these. Okay. Uh-oh, looks like I got one wrong a long time ago. Uh-oh, what happened? I must have had a bad day then. All right. All right, so then it'd be y prime equals ax to the a minus 1. All right, and there's our negative exponent. So f prime, oh, there we go. So there's that different form again. There's the prime, that means the derivative. So all we would do is we would take our x to the negative 1. Exponent moves out front. And then the negative 1 minus 1 is equal to negative 1 x to the negative 2. And then now I know what I probably did wrong on this one. We can never have negative exponents in our answer, even though they gave you a negative exponent in the problem. So one of the rules of math is you always give them an answer like the problem that you received. So since the problem has negative exponents, it should be okay to give a negative exponent answer, but I'm just going to play it safe. And this would really be the negative. We don't need the 1 in front, but we need the negative sign. And the negative exponent, do you remember what negative exponents do? They flip the fraction. So this would all turn into negative 1 over x squared. right? No more negative exponents. It flipped it. And then the negatives on top. I didn't need the 1, but now I do. But yeah, so there we go. So f prime of x is equal to, I got negative 1 over x squared. And remember, it doesn't matter where the negative sign goes, top, bottom, or in front, so long as there's 1. So I got negative 1 divided by x squared. Yep. Got it.